This is the Apollonian Gasket. It's a mathematical phenomenon that starts with just 3 circles and repeatedly adds new circles in the gaps between them. And at first this might seem like a simple process until you look at the complex mathematics behind this. And that complexity is exactly what inspired me to recreate this structure using Blender's geometry nodes. So let me show you how that is done. And in this tutorial we are going to use a lot of complex formulas, and if we would add those formulas in one by one, node by node, then this tutorial is going to take like hours, and to be honest I don't think that's really needed. So I did some pre-work, so if you go into the link in the description, there you will find a Blender file which contains node groups that already implement the formulas that we're going to use. So download that and open it up, and then we can get started. And as always, what we're going to start off with is clicking on the cube and create a new geometry node for this, and we're going to remove the group input because we do not need the default cube. And also let's actually remove this light, and let's move the camera a bit to the side. We don't really need it for now. And the thing that we want to create first is we want to create the structure of one circle that goes like this, one big circle, and then we want to create 2 smaller circles just like this in between it. And this we are going to create with 3 points. So if we do a points node, and this is going to be the bigger point, and the smaller points we want that to be 2 other point nodes. The reason why we don't just put the count to 3 over here is because I want to have specific control over the position and the radius of each point that we're adding in. So let's join these points together with a join geometry nodes. Let's connect them all like so, and let's connect it like this. And the first thing that I want to do is change the radius of the bigger point. This radius should become 2. And then for the other 2 points, what we want to do is make it that the radius of these points is also dependent on the radius of the bigger point. So let's do that. Let's make it procedural by adding in a value node, which we set on 2, and let's connect it like this. And we want that the radius of this point is half of the radius of the bigger point. So let's do a math node, which we set on multiply. And let's multiply this by 0.5 and connect it like so. The next thing that I want to do is change the x position of this point so that it is always like this in the corner of the other point. So first of all, I want to have control over the separate x, y, and z sockets. So let's do a combine x, y, z node. And now this x value, you see that that needs to become a value of 1. And you remember, okay, this is a value of 2 and this is a value of 1. So basically what we need to do is subtracting the radius of the smaller point from the radius of the bigger point with a math node set to subtract, and then subtract from the bigger one, subtract the smaller one. And that's going to be our x location. And then if you change the size of the smaller point, you see it's always in the corner of the bigger point, which is perfect. Let's make it like this. And now what I want is that the third point is going to fill this gap over here. And that we are going to do by first giving it the right radius. And the radius of this third point is basically the radius of this smaller point subtracted from the radius of the bigger point. So if we do another subtract node and we subtract from the bigger point, we subtract the second point, then you will see if we connect that, it is correct, because if we put it like so, it fits perfectly in between. But now we also need to make this x position procedurally dependent on the other 2. So if we do another combine x, y, z node, then this x position, you see that that needs to become minus 0.6. And to get to that value, we are going to do the exact same thing as we did for the second point. So we're going to subtract the radius of this third point from the radius of this bigger point. So if we do another subtract node and we subtract from the bigger point, we subtract the radius of the third point, and that's going to be the x position. Then you see it's on the wrong side, and that's logical, of course. So let's flip it to the other side by doing a math node set to multiply, and let's multiply this by -1. And then you will see it's always in the correct way, which is perfect. Let's set this on 0.5 for now so that it is perfectly aligned in the middle. And just to make this tutorial look a little bit better, let's do an instance on points node and also a curve circle to instance circles on these points. And the scale of these instances should be dependent on the radius of the points. And then you see we have perfectly created that shape that I showed you earlier. The next thing that we're going to do is adding in a fourth circle in between the gaps gaps of the other 3 circles. And that we are going to do in 3 steps. Step 1 is of course add that 4th circle in geometry nodes. And the second step is to determine what should be the radius of this new point. And then the third step is to determine the position of that point. But let's start with the radius. And the radius, we are going to determine that with these formulas. So you see the radius of this new circle is 1 divided by k. K is the curvature that this new circle should have. And to calculate the curvature of this new circle, we need this bigger formula over here. You see K4 is the curvature of the new circle. But then you see we also need K1, K2 and K3. And those are the curvatures of this circle and this circle and this circle. And to calculate the curvature of those 3 circles, we need this formula. So let's calculate the curvature of those circles first. And we're going to do that by doing a store named attribute node, which we set on k. And you see this k value should be 1 divided by the radius of that circle. So let's do a radius node with also a math node set on divide. And let's do 1 divided by that radius. And then we have calculated the curvature for those points. And now to implement this formula, I already created a node group for that. And that node group, you can find that by doing Shift A and doing new point curvature node. And you see this node group, it asks for the 3 circles that we're going to use to calculate the next circle. And you see the output of this is the curvature of the first 3 circles and also the curvature of the next circle. And let me show you what's on the inside of this. It looks like this. Okay, you don't have to know in detail what really is happening in these formulas, but I will go over it a little bit. So first of all, we are extracting K1, K2 and K3 from this geometry with the sample indexes. So this is K1, this is K2 and this is K3. Then you see in the formula, we have to add those together. And that's what I do over here. And then in the second part of this formula, you see we have to multiply them by each other. So we first have to multiply 1 and 2, then 2 and 3, and then 1 and 3. And then once we've done that, you see we have to add those together again. And that's what I do over here. And then we take the square root of that entire thing and that we multiply by 2. And then you see we have this plus minus over here. And the reason why there's a plus minus over here is because we are working with a square root, and the outcome of a square root can always be either positive or negative. But for the calculation of the curvature, we really don't have to worry about this. We are just going to take the positive number of this equation. And then let's output it like this. So let's press tab to get out of this. And now we can take this point, and if we connect the curvature with the radius, if we do a join geometry nodes, connect it like so, then we can actually see it. You see it becomes way too big. And the reason for that is that the radius is not the curvature, right? So we have to convert the curvature into the radius with this formula. So let's do a math node, which we set on divide, and let's do 1 divided by the curvature. And then you see now it's too small. And the reason for that is because we are doing something wrong in the calculation of the curvature. And this calculation over here, it is going correct for this circle and this circle, but it's incorrect for the outer circle, because as you might see, this new point is going to be placed outside of these circles, so outside of them like this, but inside of this circle. But if we calculate the curvature of the outer circle like this, it thinks that it's going to be outside of it, and that's not correct. So basically we want to flip this equation only for the outer circle. And to do this, we first have to tell Blender which circle is the outer circle. And that we're going to do with a store named attribute node. Set this on outer, and let's also set this on Boolean, and let's turn it on, of course, so that we tell Blender this is the outer circle. And then what we want to do is we want to either multiply this value by 1 for the middle circles and -1 for the outer circle. So let's do a math node set to multiply, and then let's also call the attribute from outer. So let's do outer, and then if we preview this, you see the bigger point is 1 and the others are 0. And we want to say with a mix node, we can say, okay, if it is the outer one, then do -1, otherwise multiply it by 1, and then connect it like so. And then you see the radius of the new point is exactly correct. And so the next step is to determine what should be the position of this new point. However, However, before we do that, I want to talk to you about something else, because I can completely understand if you're looking at these nodes that you're thinking, oh my god, what is all of this? How am I ever going to learn all these nodes? I wish there was just some place in which I can just learn every single node in geometry nodes in a very easy and chill way. Well, then I have good news for you, because I released the Big Notebook. It's a book that explains every single node in geometry nodes in a very easy and chill way. The book starts from the very basics of geometry nodes, and over the course of almost 300 pages, it goes to more advanced techniques. The book is available on my Gumroad, and it has been fully upgraded to Blender 5.0, so every new node has been added in. And if you use the code MAAF, you will get 25% off of your purchase. So if you want to expand your knowledge in geometry nodes, I recommend getting this book today. And with that being said, let's continue the tutorial. Next up is we're going to calculate the position of this new point, and that we're going to do with this formula. And this formula, it looks like a lot, but if you look closely, you see that it looks similar to the formula for the curvature. So we have this part and also a square root part, and the K1, K2 and K3 are also coming back. However, you also see Z1, 2 and 3, and these Z values over here represent the position of the three circles in complex form. And a complex number is basically a simple way to store a 2D vector as a single value. And in this we have the real part, which represents the X position of each point, and we have an imaginary part, which represents the Y position of each point. And operations like multiplying two complex numbers or taking the square root of a complex number work a little bit different than doing those things with normal numbers. But rest assured, I will make that all clear in a moment. Let's first focus on this formula. And this formula I also already implemented as a node group in this Blender file. So if you do new point position, then you see this node also asks for the three circles. So let's connect that like so. But it also asks, of course, for K1, K2, K3 and K4. So let's connect all the four curvatures like this. Let me go inside of this node group by pressing tab. And then you see we have the entire formula over here. Let me go over it again. Just like with the curvature, we want to get the Z1, Z2 and Z3. And that's basically just the position vector of each circle. And we do that again with a sample index. And then we want to multiply each Z with its own curvature. And that I do just with a scale node. And then once we have that, you see we have to add those together again. And that I do over here. Okay, then we get to the second part of this formula, which gets a little bit more complicated. Because over here, we are multiplying two complex numbers with each other. And multiplying two complex numbers, that goes a little bit different. It's not just X times X and Y times Y. No, it goes a little bit different. It goes like this. So if you have two complex numbers, you have to use this formula. And luckily for you, I made a node group for that, and that looks like this. But for you, that's not really important to know the ins and outs of this. So let's have a look. We multiply, first of all, 1 and 2 again, and then 2 and 3, and then 1 and 3. And then let me go back to this formula again, because then you see we have to add those together, and that we do over here. And then we want to take the square root. However, taking the square root of a complex number is a little bit different from just taking the square root of one number, because for that we have to use these formulas. And these formulas, I also already implemented them in this node group. And again, for me, the most important part is that at the end of this tutorial, you know how to really control the most important parts of this gasket, then that you know every in and out of this formula. So let's go out of this node group really quickly, because you really don't have to look at that. For you, it's more important that you actually can take the square root of the complex number. But okay, then we have taken the square root of everything that came before, and that we want to multiply by 2. And then over here we have again that plus and minus. And in this case, we are actually going to use both of them. You see, I have that over here, add and subtract. And the positive part is going to put the point over here, and the negative part is going to put the point over here. And then the last thing is we want to divide that entire thing by the curvature of that new circle, which I do over here. Let's go out of this node group again. And then you see this node group puts out the positive position and the negative position. For now, we're only going to focus on the positive position. So if we put the positive position into the position like this, then you see we have the circle on the exact position that we want. And I think this is already pretty cool progress. triplets. Cool, now that we have the fourth circle, the next step is to add more and more and more and more circles in the gaps between. So let's start by adding in a circle over here, and over there. So let's focus first on this middle circle over here. So let's make a bit more space. And this new circle, what we want to do is we want to apply this set of formulas to this point and this point and this point to calculate the radius and the position of this point. So we need to get rid of the bigger circle for now. And to do that, we are going to do an delete geometry nodes. And we want to delete the point if it has an index equal to 0. So if we do a compare node set to integer, we can say if it's equal to 0, then delete it. And you see, we only have those circles. For those 3 circles, let's do this entire thing again. So let's do Shift D it over here and let's make some space and let's connect this one over there and let's connect this one over there. Then you will see we have perfectly created that circle. But you will also see that if I set this on 1, then it will take this circle and the bigger circle and it doesn't really work. But don't you worry about that yet. We're going to fix that later. But if I set it on 2 and we take this one and the bigger one, then it does work. So we are doing it correct, but this one we are just going to fix later. That will be fine. What we want to do is we want to do this formula at the same time for each of these triplets. So let's extract those 3 triplets separately. So let's disconnect this for now and let's make a little bit more space. And what we want to do is we want to take these 2 nodes and do Ctrl-Shift-D to duplicate them twice and keep the connection. And let's put it like so. And then we want to set this one on 0, this one on 1, and this one we keep on 2. And then you will see we have these triplets. And now we want to join them together, but we don't want to just join them together with a join geometry nodes. We want to convert each triplet to an instance. And then those 3 instances, we want to join those together so that later we can separate the instances from each other. So if we do a geometry to instance node and we connect all 3 of them like this, then we have now the 3 triplets as instances over here. And now we want to do these formulas for each set of triplets. So for each instance. And you hear me saying for each. So we're going to use a for each element zone. And we want to say for each instance, do those formulas. So connect it like so and connect it like so and connect it like so. However, right now you see it's not really working because it goes in as an instance over here and over here it's still an instance. But these formulas, they don't work if the objects are instances. So we need to realize the instances so that it is real points again. And then you see we get the 3 points at the same time and that's perfect. And actually I forgot something because at the end over here, yeah, we are not creating new triplets again. What we want is that from each triplet, we are creating 3 more triplets. So this entire thing, we want to do that in the for each element zone too. So let's copy that and let's make some space and let's connect it like so and then like so and let's connect it like this. You don't see any difference, but now we are actually creating a new set of triplets again for each of these points. And from here, this entire thing, we want to do that again and again and again and again. So we're going to use a repeat zone. Let's put that over there. Let's connect this one over there and connect this one over there. And let's make a little bit more space so that it fits in between. And let's put this one at the end so that it is all within the repeat zone. And actually what we can do is remove all of this and put it all closer like so. And let's connect it like this. But then you see that doesn't work because we get an error over here. And the reason for that is because the first set of points is not an instance yet. So let's turn that into an instance. If we do a geometry to instance again, then you see that works. And if I now put the iterations higher, then you will see that already starts working over here, a little bit over here, and in the middle, it's quite a mess. But again, we're going to fix that later. Let's first make it that we're also adding in circles in the negative zone over here. And that we're going to do in a very easy way. So let's make a little bit more space over there like this. Let's do another points node and let's connect the radius with that. And for this point, what we want to do is we want to use the minus position. So let's connect that. And then we want to do this entire thing for this point too. So if we do a joint geometry again, and if you do shift right click to make a joint over there, you can connect it like so. And then we can connect this one over there. And now to do this entire thing for the negative part, let's join these connections by doing shift right click like so. And then to make this part work for the negative part too, I want to make a node group out of this. So let's select it and do Ctrl G. And then if you go out of that, you see we have a node group that does this perfectly. Let's press shift D to duplicate it. And let's connect the negative part with it. And let's also connect it like so with the geometry to instance. And then you see it perfectly works for all sides. And I think that's really cool. However, we still have to get rid of those wrong points. So in order to remove the wrong points, we want to check something. And to do that, let's actually put the iterations lower to this. So what we want is we want to remove these 3 points. And the thing we want to check is, let me go to this circle. This circle is dependent on this circle and also the bigger circle. And what we want to check is if this circle is touching the other circles in a perfect way. In other words, we want to check whether this circle is tangent to each circle that it is dependent on. And for that, we are going to use a formula, and that formula looks like this. And for this process, I also made a node group. So if we do an isTangent node group, and this tangent node group, it asks for the index of one of the 3 points, and it also wants to have the index of the new point. And the index of the new point is always 3, since we added in below the other points in the joint geometry nodes. If we have a look inside of this, so what we're doing here first is we first determine the distance between one point and the new point, like so. And then we also take the radius of this point, like so, and the radius of the other point, like so. And we want to know the difference between the total radius and the distance. Because if the difference between distance and radiuses is lower than a certain value, then it's not tangent to it. Then it will be more like this, or completely different, of course. So the output of this is if the circle is not tangent, then this value will be true. But I want to do this formula for each circle in the triplet. So let's duplicate this twice, and let's set this one on 1 and this one on 2, so that we're comparing each circle in the triplet. So I want to delete a point if either of these 3 values are true. And that we can do with a Boolean math node, which we set on OR. So if this value is true, or this value is true, or this value is true, then we should delete the point. So if we do a delete geometry nodes and we connect that like so, then you will see we have removed this wrong point already. But now for the other points that are wrong, we just want to do this exact same thing for the negative part. So if we connect that like this, then you can connect it over here. And then after all this, we have created our perfect Apollonian gasket. And I think this already looks really, really cool. I think this is one of the most satisfying things I have ever created in Blender, to be honest. However, you will see if I put the iterations on 6, you will see that it starts lagging a little bit. And the reason for that is a little bit hidden, because let me do this. Let me make a little bit more space, and let me add a set position node and a random value node, which we set on vector. I want to have a random Z location. Let's put it like this. You see, we have a lot of duplicated points, and that takes a lot of computer power. So basically, we want to merge points if they are really close to each other. So let's do a merge by distance node. And of course, that doesn't really work yet, because what comes out of this are instances. So let's realize those instances. And then you see we have a lot less points and it's a lot more responsive. However, the outer circle is gone. And I'm not really sure why the outer circle gets removed completely by the merge by distance, but I have found a way to fix this. And the way to fix this is to do 2 merge by distances. And this first one is is only going to do it for the outer circle, and then this one is going to do it for the other circles. So if we do a named attribute node, which we set on outer, we can connect this one over here. And then this one, we want to do the reversed. So let's do a map range node and connect the outer like so. And now it goes from 0 to 1, but let's make this go from 1 to 0. And then if you connect it like so, then you see the outer circle is back. Okay, the next thing that we're going to do is make this thing look more beautiful, because at the moment we are only instancing circles on this thing. But to be honest, we can instance anything we like on these points. So for example, if we do an icosphere and we connect that like so, and we set these subdivisions a little bit higher, and then you see the icosphere is also instanced on the biggest circle, but that's not what we want. We want to have it only on the smaller parts, as you can see. So let's remove the bigger one by doing a radius node, and then we can say with a compare node, we can say if the radius is less than 1.9, for example, then instance it. Let's do a set shade smooth node like so. Okay, cool. That already looks quite satisfying, I think. Let's also flatten the icospheres by doing a vector math node over here. Set this on multiply everything by 1, and let's set the z-axis on 0.3. And then you see that looks really cool. However, if I now put the iterations higher, you will see that the smaller icospheres get the same resolution as the bigger icospheres. And that's not really needed, and it's going to take a lot of computer power from us. So let's make it that the smaller icospheres are getting a lower resolution of subdivisions. To do this, we want to create 3 versions of this icosphere. Let's do Shift D and Shift D, and let's make this one a version with 2 subdivisions, this one with 3, and this one with 4. And we want to join them as instances again. So let's do again a geometry to instance node, connect that like so, and like so, and like so. However, you see it's kind of lagging a little bit, and that's because every time we change something over here, it has to calculate everything that comes before. I don't want that. I want to calculate this only once. So let's do a bake node right over there and over there. And then if you click bake, then it will calculate it once, and we don't have to calculate it over and over again. Now we have 3 versions of this icosphere. And then if you connect this with the instances, now all of the icospheres are stacked on top of each other. But let's do pick instance. And now what it's doing, it's for each point, it's randomly picking one of these icospheres. But we don't want that. We want that the bigger points should get this one, and the smaller it gets, the more it should aim for this icosphere. So if we take the radius of each point and we do a compare node and also a mix node, then we can say if the radius is less than 0.1, then it should take the icosphere with index 1. Otherwise, it should take it with index 2. And index 2 is this icosphere, and index 1 is this icosphere. And then if we connect that with the instance index, then you see it does actually filter the resolution. But we can make this go a step further, because I think these points are still a little bit high res. So we can say if the resolution is less than 0.01, then it should either take the icosphere with index 0, or it should stay the same. And then you see that is good enough. You could, if you want, take it even one step further by adding an icosphere with subdivision 1. But for now, I think it's good like this. So the next thing that I want to do is make it that we have a circle going around this. So basically, we want to instance a curved circle on the biggest point. To do this, let's make a little bit more space over here. And let's do another instance on points node. And let's connect that like so. And let's connect it with the set shade smooth like this. And we want to instance a curved circle. And of course, turn off the pick instance. And then it works. Let's connect the radius of each point again like this. And now I want to only have it on the bigger circle. So basically, I want to have the reverse of what this is. If we do a map range node and connect it like so, and we reverse it in this way, then we can connect it with the selection. Now the cool thing is, if we join these together, then you will see we have a perfect controller of where should be circles and where should be icospheres. And that's really cool, I think. But now let's give those circles a little bit more thickness. So let's do an realize instances node so that they are actually geometry. And let's do a curve to mesh node from which we set the profile curve to another curve circle. Let's set the resolution lower to like 7 and let's connect it like so. It's a bit too big, so let's set the radius on 0.1 and let's set the scale also lower like so. Let's set it like this. However, you will see that the circle is overlapping with the icospheres and that's not what we want. And to fix this, let's do a transform geometry nodes. And if we move the profile curve over the x-axis, you see we can make the outer circle already go out of it. Let's actually make the resolution of this curve circle like 100 so that we can see a bit easier what is happening. However, you see that the circles of the inside are actually overlapping even more now. That's not what I want. I want to flip this. And to do that, we can do a set curve tilt node and we only want to tilt the outer circle. So if we do a named attribute node, which we set on outer, let's connect it with the selection. And now let's tilt this 180 degrees. And now if we set this to the other side, then you will see it's working perfectly fine. Let's set the number of iterations a bit higher to like 7. And let's of course bake it again. And to be honest, then we have created quite a cool result, I think. Let me show you how to visualize this in a cool way, of course. Let's go into cycles. So let's go into render view and let's go into render properties. And let's also press Ctrl S to save the file so that it's not going to crash. And let's then set it from Eevee to cycles. And let's set device on GPU compute. And some quick render settings that I most of the time use is to make the denoiser also use your GPU. And under lights, let's turn off light tree, and under color management, let's turn our look to very high contrast because I think that looks a lot cooler. Okay, let's see. Let me position this in a cool way. Let's add in a plane and let me also make the world properties black. And let's also add in an area light like so. Let's see. That's pretty cool, I think. Let's first give each icosphere a material. So let's click on it and go over here and let's do a set material node. And let me also go into the shader editor over here. Let's name this material blobs and let's also assign it in geometry nodes like this. Okay, I'm thinking let's give each blob a random color, and that we are going to do by assigning a random value in geometry nodes. So let's do a store named attribute node, which we set on rand, and we want to give each instance a random value. So let's do a random value node connected like so. And then if we go into the shader editor and we do an attribute node, which we set on rand, let's connect it like this. Then you see that doesn't really work. And the reason for that is because we have to realize these instances. So let's do a realize instances node. And now we're getting a random value for each point. And a cool thing that I found is if you do a hue saturation value node and we set the color on red, for example, and now if we set the iteration lower, you see we're changing it like this. I found that if you give each blob a random saturation, then you're getting quite a cool result, to be honest. And another thing that's going to give this object a little bit more depth, so to say, is adding in ambient occlusion. So contact shadows between these blobs. So if you do an ambient occlusion node and we preview this, then you see we're getting the contact shadows. If you want to make that stronger, you can do a color ramp node like so. And now if we put the output of this color ramp with the value of the hue saturation value, and then I think we've gone to quite a cool result, to be honest. And if we go over here into the multiply node and set it on 0.7 and we bake it again, let's see, then you can see that you can create such cool things with this. The possibilities are unlimited. And that already brings us to the end of this tutorial. I hope you liked this video again, and if you did, please give this video a thumbs up, comment down below if you have any questions, and if you don't want to miss out on any future videos, I recommend subscribing to the channel. And also be sure to check out the big notebook by going into the link in the description to get 25% off of your purchase. And lastly, I want to give a big thank you to the coding train, because the things that we did in this tutorial are inspired by the things that he does in this tutorial. And with that being said, thank you for watching, and I see you in the next one.